For machine learning algorithms to easily process words, we would like to convert the words into a series of numbers, and a series of numbers is also can be seen as a vector. So here is a simple example. If you have two dimensions, vector 7 7 is like this. uh, and when we talk about words, the dimensions are lot many. In this case, 100 for example, but it could be 300 as well. And we want to represent each word as a point in that multi-dimensional space, represented by a vector which starts from 0 to that point. What we do is we start with loading a Word2Vec trained model, and this is one such pre-trained word vector model. Uh, Next thing we do is we try to find out what is the vector for king, and here we are showing that it's a this trained model basically supports vectors of length 100. So the king as represented by 100 numbers in 100, each on one of the 100 dimensions is like this. So this is the representation of king as per this Word2 vector. The next thing that we want to look at is similarity. So if there are two words which are similar in some way, they should be represented closer to in the multidimensional space. So for example, king and queen are kind of closer, and man and woman are also kind of closer. And also notice the direction, right? So it has to be that way. So the method for finding similarity is this. So we first tested with king. So the similarity between the two same words is 1, of course. And the reverse of similarity is distance. So the distance between these two points of these two words should be 0. So this is just for validating whether things are going fine. Now let's take some more examples. King and queen, the similarity is 0.75. Distance is 1 minus 0.75, so that's the number. Similarly, king and car, the similarity is 0.28. So what we see is that similarity of king to queen is much higher than king and a car, and which makes sense. Then we try to find out similarity between king and emperor, king and monarch, king and ruler, and they're all very similar to each other. Now we can also find out what are different words which are similar to king. The first thing that you try to find is the most similar word, and which looks like prince is the most similar word. Other words are queen, son, brother, monarch, throne, kingdom, father, emperor, etc. I don't know what is this I. Maybe two. Yeah. So this is about similarity. If two words are similar, then the vectors of them will also be closer to each other. Uh, One thing to understand is that the way this library works is that it it trained itself on huge amount of data, and when it finds the same word in similar context, it treats them as similar. So if in a particular sentence king appears, and somewhere else with the same set of words in the sentence queen also appears, so the library, the training algorithm basically treats them as similar words, and it gives them a point in that multidimensional space which is closer to each other. So that's one beauty of this embedding. The second beauty is the vector arithmetic. So remember, you could take a vector b, add a to it, and you would get this vector. And whether you did a plus b or b plus a, both will basically give you the same resultant vector. So let's do a very interesting arithmetic. So let's take king, let's remove man from it, the vector man, and then add a woman vector. And if we do this, you would see that the answer that comes for the resultant vector, the closest word that comes is queen. So basically this is saying that, take king, replaced with replaced man with women, is the queen. Another, we use another similarity measure, but the answer is similar. Now one more thing, let's say we take four words and we want to find out which of them is the odd one out, right? So breakfast, cereal, dinner, lunch. This says that cereal is an odd one out, right? So it is also able to even find out which one is odd. Now let's see whether we can extend this to sentences. Here are two sentences. Obama speaks to the media in Illinois. The president greets the press in Chicago. Um, what we are doing is we are basically splitting them into list of words, and then we are asking a word mover distance to find out whether these two sentences are same or not. And you would see that with a very high score, it is saying that these two sentences basically are same. They are conveying the same meaning.